No, there are no more questions currently, but I guess they can post some more in the chat box during the session.
Oh, that's okay. That I'm expecting anyway. That's fine.
Yeah, yeah.
I just wanted to see if they had technical questions about so much. That's fine.
Yeah.
That's okay. Albert. Okay. Okay. Also, let me know if my video is on. Will you guys turn on your videos, or like how does it usually work?
Yeah, you are
Is it
visible.
fine?
Yeah, yeah.
Okay. Lighting is fine. Everything is fine.
Yeah, everything is okay.
Great. Okay. I just hope there are no power issues while in the call. Okay.
Yeah.
Okay. Tell me one more thing. Can you see my screen go blur?
Yeah, now it's blurred.
Okay. Fine. Okay. I'm hoping the content is completed in an hour. Okay. I'll wrap it up within an hour. I don't want to exceed an hour, but we'll see.
Yeah, it's totally fine.
Yeah.
And after the slide, we can just move on to the quiz we are discussing.
You have it on Discord, no? So I'll just
Yeah, yeah.
ask you to take over.
Yeah,
Let
yeah.
me know when people start joining, and I can
Okay,
shut up about
Rajashri is
all this
here, so
nonsense.
she will be the host.
Who's
Rajashri has just
Rajeshri?
joined.
Hi, Rajeshri. Okay.
Yeah.
Hello, ma'am. Hello.
Hi. Call me Insha. Don't call me ma'am and stuff, please. That's fine.
Yeah, and also we are doing the YouTube live stream. Like the meeting has only the 100 limit. So after it reach the
Oh, okay.
100 members, yeah, that's why we are doing also the YT live. People can just join
Okay.
there and see.
Oh, okay. But you will manage the interactions on YouTube
Yeah,
with
yeah, yeah.
chat and stuff, no? Okay.
Yeah,
So just
they can
forward
just
it here.
drop some questions there also. Our core team members are there on the
And
YouTube.
if you
They will,
find it helpful, okay, just make sure you don't repeat questions and stuff. So if you
yeah,
find
yeah,
the questions are new and stuff, just send it over on Google Chat.
yeah,
I
yeah,
will see.
sure, sure,
Yeah.
sure.
Okay.
Okay.
Perfect. How many people are we expecting? What kind of workshops have you had in the past?
Actually, we have covered multiple domains like cybersecurity, GSOC also,
Okay.
cloud, and web development, DSA, and all. So I guess in the
Okay.
machine learning and AI, this is the first session, if I'm not wrong.
Oh, okay. Great. Great. And I've kept it pretty introductory because I did not have any metrics to gauge. But yeah, let's see. We'll figure it
Yeah,
out.
let's see.
We'll probably have complicated stuff later down the line.
Yeah, let's see what happens.
What is AOT? So I saw a lot of connection requests from AOT. So I'm guessing you guys are
Yeah,
from
yeah,
AOT.
yeah. We
Okay.
are from UP.
Where is this? This is in Kolkata itself.
It's in Hooghly actually.
Oh, okay.
Yeah.
Nice.
Hello, Arkudip, are you there? You are handling the Resourcio account, right? The meet is from the Resourcio account, I guess. Yeah, just check once that if you can mute or unmute anyone in the meeting. Like if any error occurs, like you have to handle those issues. So just do one thing, just check once. Okay, sure. Okay. Okay, cool. Got it. And if you will be handling the Resourcio account, or I will join with the Resourcio account after the session start. Okay. So you just stay here with this account. I will continue with my personal account. Okay. Okay. Cool. And Shayan also just check once that if the YT live stream is working or not. Output was messaging.
Okay. I'm checking.
Yeah.
Yeah, I can see the YT live stream.
Okay, cool.
Yes, yes.
Hello, everyone, and welcome to today's exciting webinar brought to you by the Resourcio community. Myself, Rajashree Rai, host of today's session. We are so glad to have you all with us today. Now you are in for a treat because our speaker is none other than Insha Manwar. Insha has over 2 years of experience as a machine learning engineer at Seek, where she works on innovative projects that push the boundaries of AI and technology. Not only that, but she is also an amazing educator and mentor, contributing regularly to our Resourcio community through insightful webinars and discussions. Before starting the session, here are some quick info for all of you. We will give a form in between the session. You guys have to fill it up for getting the participation certificate. There will also a quiz session at the end of the session. Quiz link will be provided in the meeting chat. Be there if you want to win some exciting swags. Now, without any further delay, let's welcome Insha Manwar. Ma'am, the stage is all yours now.
Thank you, Rajashri. Hi, everyone. I hope I'm clearly audible. Yeah. Can someone give me a confirmation?
Yes, ma'am, you are audible.
Yeah. Okay. Okay. Great. Yes. So I'm Insha Manohar. I'm working at Seek, which is an edtech startup based in Chicago, right? And we are working with generative AI and large language models day in and day out. Yeah, but then I want to know something about you guys, all of you here, okay? And I want this entire 1 hour to be very interactive and fun, right? So uh, we'll start. So can we have a couple of introductions, please? Because I don't want this to be a one-sided thing, okay? I want this to be fun because all of us have been working with Gen AI in some way or the other, even if you're just using ChatGPT for solving our homeworks. Yeah, Sharmajit, you can write here in the chat box or um, just unmute and speak. There's no restriction. You're not going to um, throw me off. Okay. So, anybody? There are 40 people in the meeting. Come on. It's Sunday evening. I'm sure you guys uh, like to have fun on Sunday evenings instead of watching lectures. Thank you. No? Learning ML and stuff. Okay. Okay. That's nice. Yeah. What are you guys doing right now? Are you in second year, third year? What's the ratio like? First year. Oh, okay. Grad models. Third year. EC. Nice. I did my bachelor's in Triple E from MIT Manipal. Second. Nice. Okay. Okay. Yeah, let's keep this interactive, okay? Let's keep this fun. Nice. I see you are the first years here as well. Working on AI and ML. Okay. Nice. Nice. Okay. So I have kept this session very introductory. Okay. If there is something that's confusing you, just feel free to unmute and ask questions. Okay. Because unless you ask, I will not be able to gauge what's going on in your mind, especially when I'm not even able to see you. Okay. Oh, Ankan has sent a message. Second year, currently working as intern project at Cloud. Okay. That's nice. I use ChatGPT as well. Yeah. Okay. Okay. Yes. Great. Okay, let's get started. I hope my PPT is visible. You can see the screen and you can see when I change the slides. Yeah?
Yeah, it is visible, visible.
Yeah, okay. Okay. Yeah, it's so nice when someone unmutes and speaks because I feel like I'm the only one talking. Okay. Yes. Great. Thanks, Tinku. Yeah, let's start. So, generative AI and large language models or LLMs, right? As I said, this is going to be very introductory. I'll touch the basics. And if you want to get into details, we can probably do that some other day. Okay, so what are language models? Okay, I'm sure since I saw a lot of you have some experience with neural networks, you all already know what how neural network works, right? So at the core, Neural networks are basically programs that are designed to recognize patterns. Okay, just like our brain does. Okay, and that's where this entire idea has come from. So, neural, the word itself, is derived from the word neuron, which are basically these cells in the brain that transfer your electrical signals from one neuron to the other, and that's how you uh, give responses to certain thoughts or even physical activity, right? So just like that, neural networks has interconnected nodes. Okay, and they're very similar to neurons as they're organized into layers and stuff, right? So there's an input layer here for the data, right? And then there are these hidden layers that does the processing and all the computation that it gets from the input layer, right? And after it has done the computation and everything, it sends the data back to the output layer for the results. Okay, this result could be result of a classification, right? Maybe you're trying to identify whether a certain picture is of a cat or a dog. So your output will be yes, a cat or not a cat, right? Which is Boolean maybe, or classification into categories, right? So neural networks, right? Now the key thing with neural networks is, and that's what makes it special, is that they learn over time. Okay, so as they process data, right, neural networks adjust their connections constantly, okay, based on their output, right? And all of this has a couple of other technologies here, like loss functions and gradient descents and all of this, which I'm not going to get into much details, but you get an idea, right? And there are a lot of applications every day. Like there's on your phone, you have the facial recognition system, right? And these uh, they are also based on neural networks, right? They take all the pixels as input, does the computation and returns an output, right? Then there are all the recommendation systems that recommend products that you need to buy, etc. All of that. Okay. So a large language model is a deep neural network which is trained on massive amount of text data. Okay. Now, can someone quickly tell me what is deep neural network? It's very easy. In the chat, what's a deep neural network and what's a
What was
simple
the
neural?
question?
What's a deep neural network? Why not just neural network? Yeah? No? Okay. Yes? Correct. Multiple dense layers, right? So instead of having just one hidden layer, you have multiple layers. Yeah, many layers. Okay, so that's deep, right? So if anybody asks you what large language models are, they're nothing but neural networks trained on massive amount of text data. Okay, ChatGPT is not magic. Okay, uh, moving on. Yes, correct, Mayuk. Okay, but why large language models, right? We used to we there are a couple of language models that exist, right? That can do translation and question answering, right? Why large? Okay, and that's practically because these models have been trained on a huge corpus of data, right? And they have a large number of parameters, right? For example, the GPT-3 model that came out had multiple variations in 2020, right? And the smallest model had 125 million parameters, and the largest model, the Beast, had 175 billion parameters, which is huge, right? And not only that, these models, since they have been trained on such huge amount of data and has these many number of parameters, can do a wide range of tasks, not just they're not restricted to a single task, right? You have seen in ChatGPT, they can do question answering, they can translate to different languages, they can analyze sentiments, novel text generation, and a lot of other applications, right? They can write code, okay, right? So large, and this is a good representation. So GPT-1 that came out, I think around 2017, had 117 million parameters. GPT-2 had 1.5 billion parameters, and then in 2020, 175 billion parameter model GPT-3 was almost a 100x, more than 100x increment, right? So you can see how we are approaching a huge, uh, even larger language models, right? This again is a graph from the Nature magazine, right? So you have, we used to have back in 1950 small models which had 10 to 100 parameters. Now these parameters, the word that I'm using, are basically all the things that you can change in your model when you're training, right? So all the things that you can, uh, what's that word? Uh, make changes to tweak, right? When you're training your model. So there used to be 10 to 100 parameters only. And then soon in 2010, we started to have 100 million parameter models, and we're soon going to touch a trillion model. I'm not sure. Have you guys seen the news? Do we have a trillion parameter model yet? I don't know. If not, we are probably working towards it as we speak. Okay. Right. Let's do this quickly. I get a lot of questions uh, on LinkedIn and when I'm talking to students. Uh, can someone quickly tell me the difference between AI and ML? Just unmute
Ma'am,
and start
ML
talking.
is
Yeah, Shubham.
ML is a subset of AI, and AI is a more like diverse field, and it has computer vision and NLP and other stuff also
Mm-hmm.
as well.
Mm-hmm.
And ML
Okay.
is just the practice of mathematical terms, so we can make models for LLMs.
Right. Okay. Okay. That's correct. Yes. But how can you very clearly understand the difference between an artificially intelligent system and a machine learning model?
A machine learning model can predict data based on
Okay.
uh, based on the neural networks weighted bias, biases, and artificial intelligence is basically the parent of that. So it consists of many of the things, and one of the thing is machine learning,
Okay.
and artificial intelligence is also like the ability of cognitive thinking ability to the computer, so they can think artificially, but they're not actually um, I mean, like, they're
Yes,
not actually.
that's yes. So, for example, when you are experiencing a chatbot system, right? When you're maybe on a flight website and you're trying to book a flight, and you go into your chatbot, you see a couple of options there, right? You see book a flight or maybe track status, right? So if Shibam and his friend goes and plays around with the chatbot and clicks on the same options, they will get the same results, right? Especially in the back, historical times when these models did not have Gen AI with them, right? So you will get a same rule based approach, but these chatbots are intelligent. They do behave like a human. You will, if they are very very well trained and made, you will feel like you're talking to an actual assistant, right? But the thing with these chatbots are they're not learning over time, right? They won't learn based on uh, what you tell them, right? They still follow these rules that they have preset. Okay. So artificial intelligence models are any machine that remotely behaves like a human. Okay. For example, these chatbots, but it's not learning over time. Okay. And within that, we have machine learning, which is basically models or machines that learn based on how you interact with it. Okay. Is that clear? Yeah. Right? And then we have deep learning. So deep learning only involves neural networks. Okay. Machine learning can have neural networks, or it can have other methods of training like you decision trees like these, right? So this is, I think, an example from a heart disease prediction, right? This doesn't have a neural networks, but it's a decision tree, and it's learning over time. So it's a machine learning model, but not a deep learning example, right? So that's deep learning versus machine learning. And then within deep learning, you have large language models. Okay, because large language models only deal with text, right? Deep learning model can also deal with images, okay, and videos and other sorts of media, but large language model only process text. Okay. And then when you combine large language model and deep learning model, you get generative AI, okay, which is a deep neural network that can create content, such as text, images, and various forms of media. Okay. Is that clear? Does anybody has any doubt in this part? Oh, I see, Shubhanil. We have already reached trillion parameters. That's amazing. Okay, this is clear. Yeah. Okay, great. If you have any doubts, just speak up. Okay, interrupt me anytime you want. This here is something you can go on your browser and check out later. Okay, this is a good animation of a neural network, and you can actually see the neural network in action for image prediction, right? So this is a convolutional neural network. And let's come to this. Okay, let's dive into generative AI now. Okay, now let's do this in a very interactive way. I am hoping all of you have had some experience with ChatGPT and have read some articles about Gen AI and stuff, right? So imagine, and we're not going to get into details of what architecture we are using or what we're doing, right? Let's just focus on the data. Okay, so let's say you want to create an app, okay, that answers fill in the blank questions or generates fill in the blank questions. Okay, so what will be your first step? Like, right, what will you do first? This is your problem statement. You have to develop a model that can do fill in the blanks from, let's say, only physics. Okay, so how will you go about it? Come on, let's do it together. Focus on the data. Okay, let's not get into what model we're going to use, anything, just the data. What sort of data do you need? Hire a data scientist. No, let's just try. We all engineers here, right? So let's try our hands first. Let's just say it's your startup and you want to build this. Yeah, no, you want me to be able to give the solution? Just take LLM model and fine tune the what data set. Yeah, so fine tuning is fine. Fine tuning you can do very easily. Okay, but your data is very important, right? In fact, it's the most important step in any machine learning project. By using an LLM with a proper data set. Yes, so fill in the blank question. What kind of data set are you going to use for physics? Scrape data. Okay, so let's say we scrape data from Wikipedia. Okay, we scraped all the physics articles we could find from Wikipedia and we have our data. Okay, what next? What can happen with the data? Data with keywords, yeah, sure. So we have all the physics data. Now, let's say during scraping, you because Wikipedia is dense with text and all this, maybe you get some characters and emojis that maybe you will have to eliminate. Okay, so you do pre-processing with the data, you clean that data, right? Aggregate the data. What do you mean by aggregating the data? We have to vectorize it. Sure, we'll come to vectorizing as well. Let's just get the data. Yeah, then we use regex. Okay, so we use regex for cleaning, I'm hoping. And we normalize it. Okay, we have a lot of ideas here. Amazing. Great. So yeah, so let's do this. You have the data from physics. Okay, you get the data, you clean the data. Now you break the data down into sentences. Okay, you use regex, you use tokenization, you break your uh, data into sentences and question answer pairs. Okay, so you have a sentence, you remove a fill in the blank possibility, you add an answer, and you create pairs like these, right? Hundreds of pairs. Okay, is that clear? Right? And once you're done with this, once you have enough data, you train a neural network on it. Okay. Keep in mind, you're not labeling your data here. You're not telling the model that this is a fill in the blank question explicitly. Your model will understand based on the kind of data you're providing to it, right, about what it is. And this is why your data is very, very important. Any generative AI model that you're fine tuning, pre-training, or using a rack pipeline, whatever, your data, and I cannot emphasize this enough, is most important because there's a garbage in, garbage out policy. If you're given bad data, you'll get out bad data. Okay, so data is important. So you do all of this, you get physics articles, and you feed your neural network, and you get an output, right? And let's say your model works fine. Okay, and now you get this crazy idea to take all the Wikipedia articles, okay, every news article that you can ever find in the web, all the books that you have, and you train a huge neural network, right? And that's where you get the large language model. Okay, it's just that simple. Okay, and then yeah, there are all these models. There are text-to-text models that have come up. I'm sure all of you must have tried many of these already. There's text-to-video model, there's text-to-image model, all this. Did you guys experiment with the image generation models? They're all fun, right? Right. And then, yeah, as I said earlier, as I mentioned, that there used to be NLP models that was designed to do a specific task. Like we had models that did only translation or models that did only summarization, right? But these LLMs these days can do all of these, right? And you don't need separate models for that, right? So why is that the case? Okay, what's the secret sauce here? Can someone give me an answer? How is this possible? Guess, make a guess. Parameters, yes, but we already have, yeah, sure. What else? There's one particular thing that I'm looking at, and I know all of you know this. Gen AI, we're talking about Gen AI here. What goes into Gen AI? What's in the background? Transformers, correct. So your secret sauce is none other than the transformer architecture, okay, which came out for the first time in this paper called Attention is All You Need, which was released in 2017 and in 5 years had 100,000 citations, okay. So any of you who wants to get into research and is hesitant that you do not get enough attention, well, this paper proves you wrong, okay. So and this paper is so dense with information that it will take me a couple of hours to explain, right? And I'm not going to get into that, but I will do a simplified transformer architecture if you're interested. Okay. Uh, has anybody read this paper and understood?
I have read it, but
Oh,
it's not. Yeah, it's. I have not understood it to that point of extent, but I've understood how they get the weights and how they get the biases and how they use the embeddings to find the
very good.
collectiveness of the data and how it's different from for the same word, how it's different in the place of its context. Like a word might have a different embedding value based on which context it is being used. So I
Right.
understood that much,
Okay.
and I have actually tried to recreate this paper, but Google Colab is not liking that. Google
Yeah.
Colab is really not liking that.
Yes, we have issues with GPUs. Yeah, it's always a hassle, correct. But that's amazing. I'm so glad that you went ahead and did it. That's great. Um, yeah, and I agree. It's very dense. So this is the actual transformer architecture, the neural network that they're using, right? And it does look complicated, but once you get the hang of it, it's pretty simple, right? Nothing. And I'm going to simplify it, okay, into 8 steps. Okay, and we can probably even get into details of this maybe in a later talk if you guys are interested. But let's do this. Okay, let's break down the transform architecture into a couple of steps. Okay, so we're going to look at an example, right, for which this machine was originally trained. Okay, and that is translating English to either German or French. Okay, now the first step here is we start with our English. Example, right? Okay, so here's one mistake I have done. Huh, this English input is supposed to be, this is an example, okay? Ignore text for now. Yeah, okay. So we give our uh, system the input, okay, which is in English, okay? That's the first step. And then we go ahead to pre-processing, okay? Now we can't just throw this sentence at the model as is, okay? We need to break it down using a process which is called tokenization. Okay, so imagine we are splitting a sentence into individual words and giving each word a unique number. Okay, it's a bit more complex in reality, but let's just say that one word is one token. Okay, just like here. So you have the original text, you break it down into words and you different characters, right? And you assign each of the word a token. Okay, a unique identifier number. Okay, that's your pre-processing step. After you're done with pre-processing, next we have the encoder. Okay, now this is the understanding part of the transformer. Okay, it takes the tokenized words and starts to make sense out of them. Okay, so once you're done with the encoding, you pass it on to the embedding cell, right? Which uh, yeah, so the embeddings is so after we're done with the encoding, we pass it on to the vector this embedding model, which generates vector embeddings for our text, right? So it's just converting the words into a format that converts a semantic meaning. So far you have broken down your sentences into words, and they're probably going to be thrown at your model in alphabetical order or something, right? Which is not going to make sense when you bring them back in together. So to make sure that world your model understands that world comes after hello, you need to capture the semantic meaning, and that's where the vector embeddings come in handy. Okay, so you take all your data, you pass it to the embedding model, it generates numbers. So embeddings are basically numbers based on the relationship between the words, okay, and how they are closely put together, right? For example, yeah, this is a very good way for me to explain. I'm sure you must have heard this example before if you try to understand vector embeddings. Okay, but for those of you who is new to this, let's uh, get into this. Okay, so let me break it down for you. So imagine we have this magical space, okay, and all the words are floating around as points. Okay, these are all the points that you have, and each word has its own unique position based on its meaning and how it relates to other words. Okay, now in this space, king and man are pretty close to each other. Okay, they're both male, both human, that kind of thing. Yeah, but king has this extra royal vibe, okay, that the man doesn't, right? So when we do king minus man, it's like we're removing the maleness from king. Okay, so what we're left is essentially the concept of royalty floating around in space. Okay, then we add woman to royalty. Okay, and we're like, hey, give me something that's royal like a king, but female instead of a male. Okay, and the point where we end up in this space is super close to where queen sits. Okay, so because queen is exactly that, right? It's royalty but female. So it's like word map equation that actually makes sense semantically, right? So this is what vector embeddings do. They uh, take all your input, creates vector embeddings based on what the words are there in your input text, and then it passes on to the decoder. Okay, so here's where it gets interesting. Okay, so our the whole transformer, the entire input that you send, they're not translated at once, right? It goes word by word. So by the time it's working on example, you already have this is and translated to German here. Okay, so you take whatever you have, which acts as input step for the decoder. Okay, the same pre-processing step that you did here. Now the decoder will have two inputs. Okay, it will have the embeddings and it will have the pre-processing, the translated pre-processing data, right? So the partial output and the embeddings goes through the same process as the original English written, gets tokenized here and prepared for the next step, right? So the decoder is the basically the writing part of a transformer. Okay, it takes a look at the English text and the partial German embedding translation, right, and then predicts the next word. Okay, so based on the graph positions of the words and the input, you get the next translation of the word example, that is BSPL, or however you translate that or pronounce that in German, right? So this is a simple uh, simplified version of the transformer architecture, right? Does anybody have any question on this? Is there any step that you'd like me to explain again? Yeah, sure, Devarshi. Tell me.
Now, when you said about the vector embeddings are
Yeah.
usually three-dimensional, right?
No, it can be. No, no, no,
But
no. So that's why,
those
yeah, vector embeddings can
it can be
usually
scaled, right?
are 500.
Okay, okay.
500 is still less. Okay, so you have 528 dimension vector embeddings, which you cannot even imagine. Like we as
Yeah.
humans are not capable of
Yes.
imagining 500 dimension space, right? You have 2048 dimension
Yeah.
vector embeddings, right? So they're huge.
So my question is, why did they decide to that? They need that many dimensions. Like three dimension
Yeah.
should be enough, right?
Three
But they
dimensional.
decided that we should do.
Yeah, so it's enough for us because we are used to seeing 3D stuff, right? But when we are dealing with text, it's easier and you can capture the text more semantically when you have a huge area to play with and a couple of more dimensions, right? So you can create even minute uh, similarity between the embeddings, right? Because once you're done with vector embeddings, when you're trying to match them, you use similarity indexes, right? You use cosine similarity to find the distance between the two words and see how similar they are. The more similar, the more closer to each other they are, the more semantically closer, right? So basically, the cosine similarity between king and man will be very close, let's say 0.9, okay? And similarity index between king and woman will be less, it will be 0.6, right? So to capture all of this information, 3D is not enough, right? You need more space because of the huge vocabulary that we have, right? And the more space you have, the more accurate your embedding models become. So if you have played around with different kinds of embedding models, you'll find that the smaller models that are basically 528 dimension is okay, but as you keep increasing the number of dimensions, it becomes more accurate, right? Your result gets better. So that's there. And the one thing different in the GPT is that your GPT models that the OpenAI designed doesn't have the encoder architecture. It only has the decoder architecture. So it figured they can do with embeddings. Like after tokenization, they give it to the embedding model and then the decoder, which again decodes the numbers back into uh, text, finds the similarity, takes the input from German, and keeps giving you the output. So this is just two layer. Essentially, there are many, 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 many such layers. Okay. Okay. Yeah. Self attention. So the title of this paper was "Attention is all you need," right? So self attention is okay. So to understand, if I had to ask you, right, which TV series does this dialogue belong to, right? The dialogue would be a Lannister always pays his debts. Okay. So to answer this question, your mind won't pay equal attention to all the words in the sentence. Okay. In fact, if you have watched the series, you would know just from the word Lannister that this TV series is Game of Thrones and the dialogue is said by Tyrion Lannister. Okay. So you're paying attention to the word Lannister, okay, instead of the whole sentence, because that's the only important part. Okay, so attention mechanism is based on this common sensible intuition that we attend to certain part when processing a large amount of information. Okay, so I'm not going to get into a lot of technical details in this because it will take hours. Okay, and had only till 9 p.m. I'm exceeding time. All right. So again, back to a comparison again, transformer versus LLMs. Not all transformers are LLMs. Okay. Transformer can also be used for computer vision, and not LLMs are transformers. Okay, because LLMs can be RNNs. Okay, if you have read what RNNs are, they do not capture long range dependencies. Okay, but they are still good at making some predictions. Okay, so it can be RNNs or convolutional architectures. Okay. GPT models. The first model came out in 2017 introduced in the paper "Attention is all you need." And soon we had the GPT, okay, in 2018, then GPT-2 in 2019, and in 2020, the one that made so much noise and still is the GPT-3. And then we have currently GPT 3.5 and GPT-4, right? Zero shot and few shot learning. So model performs fast. So zero shot is when your model can perform well without any examples. And few shot is that when you give your model some examples to show that this is an English text, this is a German text, another English text, German text. Now take this new text in English and convert it to German. Okay, so it performs well when you give it some examples. And they have mentioned in a paper, okay, I don't remember the name of the paper, but these GPT models, they perform well at few shot learning. Okay, they are better when you give it some examples, and you can use this technique when you are prompting your model to do some tasks as well. Okay, you must have noticed if you give it some examples prior, it does a better job. Okay, as I said, the GPT architecture only has the decoded block; it has no encoder. GPT-3 has 96 transformer layers. Okay, which is a lot, and 175 billion parameters, which is why it took so long to pre-train the model. Okay. Autoregressive, yeah. So autoregressive is what helps the attention and the model to perform so well, is because the previous output, right, are used as input for the future prediction. So whatever you have as the previous output will be all carried forward to the future prediction, right? So it makes it more intuitive and human-like, right? Unsupervised learning was used in the training process of the GPT model. Basically, you're not labeling your data, you're just giving it a lot of text, and the model starts to learn on its own. Okay. Again, autoregressive GPT-3, yeah, because of the huge amount of data that was used, the training cost was $4.6 million, which is a lot, right? And also because of the huge number of training and the transform architecture and the way the model was trained, GPT has something called an emergent behavior. Okay, even though you're not explicitly labeling your data or telling the model what to do, it is able to perform tasks that it was not even trained for. Okay, for example, translation, MCQ generation, summarization, right? And this is a very active area of research if you're interested in research, to understand why emergent behavior happens when model is trained on, just text data. Okay, it can do well on translation when it has not even been told what translation is, right? So this is emergent behavior and something you can read about. It's pretty interesting. Fine tuning and pre-training. Okay, I want you guys to guess what fine tuning and pre-training is. Someone, come on. Can you explain RAG? I'm going to explain RAG, yes. But let's cover this first. What is fine tuning and pre-training?
Ma'am, can I say?
Sure, go on.
So fine tuning is taking a pre-trained model and providing custom input and custom output to tell the model what kind of a output we want from unseen input.
Yeah, yeah, correct. Okay, you're right. You're right. So you have a pre-trained model that was trained on all of these data that we discussed, right? The huge amount of data that we gave. And now you are trying to make sure that your model is, yeah, tweak parameters for precise output, yes, but what precise output, right? So why do you need that precise output? So maybe you're working for a company that needs its own system where it can answer questions on the company data set. Okay, so what you do is you take the company data, you pre-process your data, you do whatever you have to do with the data, you tokenize it, and then you train an already pre-trained model. Okay, you just tweak some of the weights and the parameters, and you fine-tune this model on the company data. And now your model can perform and answer questions based for this company as well. Okay, so you're making all these already existing. Is this the same as no reinforcement learning? No, it's not. Reinforcement learning is when I'm sorry if someone. So these are the questions on the chat. If someone is confused why I'm right. So the reinforcement learning is when you give the model a reward for answering correct, right? And uh, and a negative uh, reaction if it answers wrong. Okay, so it's a completely different way of making a model, training a model. Okay, fine tuning is just taking data and tweaking with some weights, the last couple of layers, and uh, adding your own data to the already trained model. So your model can now do well on your company data as well. Okay. Uh, for example, this. Okay. So we already had OpenAI. Okay. But then another company, okay, created a chatbot called Harvey, which is good at answering. It's basically a legal tool for attorneys. Okay, so they trained it on language data. Sorry, legal data and all of these, and now this chatbot can act as a legal tool. Okay. You can see in some cases, organization need to train a purpose-built model from scratch that understands their business, industry, or domain. Okay, so this is what fine tuning does. And then we are coming to RAG. Okay, someone asked me to explain RAG. Yeah, so what happens is sometimes it may happen that you do not need fine tuning. Okay, maybe you're dealing with a model that is already good. Like you have the output that you need. Maybe ChatGPT is answering all the questions that you need for your project, but you feel there is some mismatch, and for certain questions you need to uh, provide more information to the GPT. So instead of spending dollars on fine tuning a model, you decide to provide the model with some extra context. Okay, so along with the prompt, you give your model another piece of text that explains that has more information, and the model will use that information and the prompt to generate an answer. Okay, for example, let me see. Right. So this. So you're building a project. Okay, you try first to experiment with a GenAI model. So your question is, how do I turn off the automatic reverse braking on the Volvo XC60? Okay, so Volvo XC60 is a car that came out after GPT-3 was released. Okay, so GPT-3 has no information about what Volvo XC60 does and anything at all. Okay, so if you ask it such a specific question, your model will give you an answer, but it will be an hallucinated answer. Means you will feel that the answer is correct, but in reality is not. Okay, so that's hallucination. And the models do it a lot, so you have to be very careful in using the data that GPT gives you, right? So your model says press the settings button on the center console or steering wheel. So this is a very generic answer. Okay, it's not specific to Volvo XC60, and we know this because XC60 wasn't even released. Okay, so what you do is you decide that you have the user manual with you, right? So you take all the Volvo user manuals. Okay, you pass it on to the embedding model. You generate the embeddings for the because uh, you need to store this data in a vector database. Okay, or even if it's not in a vector database, you need to convert it into vector embeddings so that you can do a similarity search between the prompt and the correct snippet from the user manual. Okay, you cannot always take the entire user manual and give it to prompt, and you will be raking up your OpenAI bills like crazy. Okay, so you do that. You take your user manual, you pass it to the embedding model, you generate embeddings, and you either store it in a vector database or you can store it standalone file as well. Okay, depends on the size of your vector embeddings, right? So you do this embeddings. Okay, so now you have the embedding model and the vector database. Let's say, okay, we chose to go ahead with vector database. Now the user will give a query, okay, which also goes through an embedding model. So now you have the query plus the embedding. Now, as I said, your query is also in the same embedding format. Your user manual information is also in the embedding format. What you do is you do a cosine similarity between the query and the embedding data. You find the similar uh, most similar snippet from this user manual, and you pass it along with the query to the generative model, and now the model has more information from the manual and can now give you an answer that is very specific to XC system. Okay, does anybody have any doubt here? Was this clear? Do you understand? So along with when you're converting this to vector embeddings, the first step is, if you have a huge textual data, you chunk it. Okay, you break it down into pieces, and then you make embeddings, and then you find the closest chunk to your prompt, and then you pass that prompt and the chunk to the GenAI model, and now you get a more refined answer that sounds like a human and also acts like a precise chatbot and does not hallucinate. Yeah, is this clear? Has anybody worked with a rack pipeline before?
So we perform the cosine similarity between the query embeddings and the embeddings metadata.
So embeddings plus metadata. So this flowchart basically says this embedding, and then this metadata can basically be so your manual can have multiple different car data, right? So your metadata will be matched to XC60 in this case. So that's a metadata. Your cosine similarity is between the prompt and the chunks in your manual. So maybe you break down your manual into chunks as paragraphs. So each paragraph is a chunk. Okay, so you find the closest paragraph to the prompt. Okay, for example, what was my prompt? My prompt was, how do I turn off the automatic reverse braking? Okay, so it's highly likely that the manual will give you a paragraph that only talks about automatic reverse braking and is closest to the prompt. Okay, so you get that paragraph, and then you pass it on as context along with the prompt to your model. Is that clear?
Yes, got it.
Okay. Debarshi send me a GitHub. Sure, I'll check it out after the call. Great. But is that clear? Yeah? Anybody else have any doubt? And your cosine similarity, not this similarity, you can try out different kinds of metrics, right? You can do cosine similarity, you can do Euclidean distance, you can do different stuff. Maybe something new came up. Okay. So all of that. Right. Questions. Okay. So far, anybody has any questions? Let's do this. And it can be anything that is in the call. It could be specific to a project that you're working on or something that you have read or anything. Let's do this. Come on. We have 50 people in the meeting. No one has any question? Was I that clear or was I not clear at all? You can put up your question. Is hallucination? Yes, it's a very big problem in GenAI. It is because especially when you're dealing with math problems or you are doing, even when you're coding, right? So your model may give you code or solution to your math problems, which are not really correct. And you must have seen a lot of memes on it as well, right? Hallucination is a big problem. Yes. The new strawberry model that OpenAI has released, it does some reinforcement learning on it to avoid hallucination, but we still have a long way to go. Is there
I don't have
anybody?
a query. I don't
Yeah,
have a
sure.
query, but you talked about cosine similarity, but I have worked with dot product similarities and cosine
Okay.
similarities. So, yeah, can you please tell the difference between those two?
You have
I
to,
no, but
yeah. So all you have to do is when you're building a project, the first thing you do is, since you said you work with dot and cosine both, right? So whichever works the best for your data and your embeddings and your use case is the one, right? So if you feel the answers when you do cosine similarity is better versus dot similarity, you go ahead with cosine similarity. Maybe dot similarity performs better, so you go ahead with dot similarity. Maybe you combine both of them and get an average, right? You can do that as well. It all depends on your application. And this is a very experiment based field, especially with data. Okay, it's all data. Fine tuning you can do easily. You just have to decide on a couple of parameters, see what works best, and do. But if your data is bad, you're going to waste dollars on training and fine tuning. Not training, but fine tuning. You're going to waste a lot of money. Is there anybody working on a Gen AI project? Devarshi, yes. Anybody else? Or has experimented with OpenAI APIs and stuff. The reason I did not do a hands-on thing this time was because I wasn't sure if you guys had access to OpenAI APIs because they're all pricey and stuff. I did not want to do that. But do keep reading papers. Okay, I did get a lot of questions from you guys on the form uh, about how to get started with ML and Gen AI and all of this. Well, to that, the best thing to do is uh, read. Okay, read a lot of papers and practice math. Okay, so when you're clear with certain math domains like statistics and probability and algebra, okay, it's very easy for you to grasp machine learning concepts. Okay, and once you have done that, once you know math very well, when you start, um, understanding ML algorithms and all of that, you will start getting a better hang of it, right? And then you can explore generative AI or maybe vision models, right? So that's there. So I guess that's it. If we do not have questions, we can. Is it possible to have Gen AI for specific purpose instead of general purpose like ChatGPT? Yeah, yeah, you can. So if you want to build an app that only generates fill in the blank questions, right? You can prompt your model in the backend, right? So you have this entire Python setup, right? So the first step is when a user gives you an input, okay? You take the input. Let's say you are taking input as subject and number of questions, okay? So your user says geography and 5, okay? So you take geography and 5, and you already have a preset prompt, okay, which fills in using the input data. So you're prompting the model to the user. You're good at generating fill in the blank questions, and you generate 5 fill in the blank questions on geography, right? So your model is only designed to generate fill in the blank questions now for your app, okay? And then you put guardrails in place so that if you get anything other than an academic subject as input, your guardrail can identify that and uh, not return content that is not suitable for your app and stuff. Okay, so you can do that. So you can, using prompting and RAG, you can make your model do only specific things. That's what a lot of startups are doing these days, right? Aniket raised hand. Right. So if you have any other questions, you can also reach out to me on LinkedIn. Yeah, that's fine. Okay, cool. Aniket, did you have a question? Oh my God, that's okay. No problem. That's okay. All right. So I hope you guys enjoyed this and it was helpful to some extent. Yeah. But you guys need to talk more. Okay.
Yeah, ma'am, it was good, and yeah, I learned a lot of things again, and some of the topics got refreshed a lot.
Yeah. Okay. Yeah. Keep learning. Keep reading papers. Can you tell us
Yeah.
about what kind of projects you made? Okay. Fine. I'll spend. So I work at Seek. Okay. Seek is an edtech startup. We are launching very, very soon, and I would love you guys to try out the app when we launch. So we are building an edtech platform where you can upload notes. The system will give you back topics. It will give you quizzes based on your notes and based on a lot of. So you have flashcards, you have summary of your notes, all of that, right? So working with that. I have worked on the entire back end of this project. I have made a serverless architecture for um, generating these quizzes. We have fine-tuned models. We have subject specific. So we're not relying on ChatGPT, right? We are doing our own in-house fine-tuning of open weight models, right? And yeah, I think there's a quiz as well that these guys plan for you. So I think that's you guys can handle that, right? So yeah, that's what Seek does, and it's going. We're gonna go online real soon, probably by next week, and I'll share it with you guys when we're out.
Yeah, so I guess we can start the quiz now.
Great. Okay.
Okay. So just see that I have posted the Discord link in the chat. Just join in the server, guys, and heads up to the hashtag general section. The quiz will be starting in next 1 minute, I guess. Our Discord moderator is there to start the quiz, so just join the server as soon as possible. And we are starting the quiz within 5 minutes, maybe. And also just fill up the form if you want to get the participation certificates. If you guys have joined the Discord, please send a message in the chat box, then we can start the quiz.
Yeah, and once you're done with the quiz, if you have like doubts about the questions, do reach out to me. But I guess it should be simple if you paid attention.
Yeah.
Yeah.
Okay, Shivam has joined. Okay, then let's start with the quiz.
Thanks, Arkadeep. I am excited to see what you do with machine learning as well. All of you. I would urge you, especially when you're learning about machine learning algorithms, it's a good practice to do it from scratch, right? So if you're learning about k-means algorithm, do not use the frameworks or anything. Just try your hands at coding it up from scratch, right? There are a couple of GitHub links and YouTube videos that do that, and you just get better at it if you try to do it. And then once you know how things work, you can always use frameworks. Especially, I see a lot of people using LangChain and all of this, but you shouldn't really do that when you're starting out, right? So just use the plain old Python, create your own pipelines, and play around with it.
Yeah. Also, I just got a doubt in the sheet, so I just put the question in the chat
Oh,
box.
okay. Is prompt engineering even dominating web dev these days? Um, in what way? So does is the author of this question in the group? If you're talking about the job role of prompt engineering and web developer, I'd say they're still pretty very two different things, right? So prompt engineering is when you have an AI system. Web dev, you can need to demo your AI systems, right? What resources we can follow to, so yeah, let me go and get the first one. So yeah, prompt engineering and web dev are two very different things. One cannot dominate the other. You can become a better web developer by using GPT to maybe code, but I really doubt that. What resources we can follow to learn LLM as a first year student? Resources you can follow to learn LLM. Hmm. Okay. There are pretty good courses on YouTube by uh, Vizwara. Okay, Vizwara is a channel which has uh, codes about for neural networks and for LLMs from right from scratch. So you can do that. Then there you can, if you know some things about LLM and generative and you have the basic idea, you can follow Andre Scarpati's videos. You can read articles. Why do we need vectors of more? And to be good at LLM, you also need some background in natural language processing, right? Of how to tokenize, how to understand the different, uh, whatever happens with an LLM is basically all natural language processing. So if you're not good at NLP, if you don't understand NLP, you will not understand LLMs. Why do we need vectors of more than three dimension in transform model? Because of more accuracy, right? You are very restricted when you're in a 3D space, but when you increase the number of dimension, your model keeps getting better and better and better. You can try out a hands-on thing where you take a sentence transformer model from Hugging Face, right? If you have not heard about Hugging Face before, it is a repository of a lot of plenty of different kinds of models, right? So you take a Hugging Face model, use a Transformers library to run that model on your computer. Take a small model, okay, maybe approximately 500 dimension vector. Do some vector embedding use on some text that you have, right? Do a cosine similarity and see how what the scores are. And to compare it, take a higher dimensional model, right? And work with that. So you'll see the difference between the accuracy of both the models. So it's all experimental in nature, especially when you're doing your own project and stuff.
Thank you for this wonderful session, ma'am.
Thank you,
Good night.
Rajeshri.
Good
Good
night.
night.
Good night, everyone.
Good night.
Yeah. Good night, everyone.